Okay, so we're going to be dividing polynomials today, and it can be done using an algorithm that's similar to long division of natural numbers. So we're going to start by looking at a long division problem. So you got to like go back to, I don't know, 4th or 5th grade and try to remember how to do division. And I'll remind you, and division of polynomials is going to be really, really similar. Okay. Okay, so let's look at the standard division algorithm, and I'm going to do 11 into 787, right? 787 divided by 11. So what's the first thing you do if you're going to carry out this long division algorithm? Okay, break it down. Okay, you'd say, okay, 11 goes into 78. Why'd you go the 78? Yeah, it's the first. So you start with the 7 and you say 11 doesn't go into 7, go another place over 11 into 78. Okay. So how many times does 11 go into 78? 7 times. So I put a 7 above the 8, right? I line up the place values. And then you do 7 times 11 is 77, and you subtract. All right, so then you'd say, okay, well, 8 minus 7 is 1, 7 minus 7 is 0. I have 1 left over here. And then what? Bring down the 7. Yep. How many times does 11 go into 17? Once. So I put a 1 there. 1 times 11 is 11, and I subtract. 17 minus 11 is 6. So that 6, what do you do with that 6? 6 over 11, yeah, if you're in 5th grade. What if you're in 4th grade? You just write like R6, remember it's the remainder. Yeah, or you could add a decimal place, 0.0, and bring down the 0, right? So we're going to go really old school and write remainder 6. You don't remember that? Well, you might have learned it a different way. How did I know that I was done? How did I know that that 6 was the remainder? 11 doesn't go into 6, right? Okay, so I'm now going to do the division algorithm, but I'm expanding it using place value to try to make it a little clearer, like what is happening in this algorithm, because this is a procedure that we all learned that has very little meaning of why you do what you do. So to give it some meaning, I'm going to try to use place value, and then we're going to extend this to polynomials. Oh, but first we should check. So my answer was 71. So it says the divisor times the quotient plus the remainder should equal the dividend. So my divisor was 11. That's the number that is going in. Okay. My quotient was 71 plus my remainder, which was 6. Right. 11 times 71 plus 6. Somebody have a calculator? 787. So because it comes out to 787, we got it right, right? It comes out to the dividend. Okay, so using place value. So I rewrote 11 as a 10 plus 1, and I rewrote 787 as 700 plus 80 plus 7. Broke it out by place value. All right, so now the first thing I'm going to ask myself here, I'm going to look at the tens place and do tens into the hundreds. Okay? How many times does 10 go into 700? 70, yes, 70 times. Okay, so I'm going to put 70 over the tens place. And then when I multiply, I'm going to get 70 times 10 is 700, and 70 times 1 is 70. So I'm doing a very similar algorithm. Maybe I should, all right, let me start over. Getting a lot of ha's. All right. Yeah, I think I'm going to put it over the hundreds place. I changed my mind. Yeah. So 10 goes into 700 70 times, right? So I'm going to put a 70 over there. 70 times 10 is 700, and 70 times 1 is 70. So 770, that's exactly what I have over here. I just represented it as a 77, and I have a 7 in the hundreds place and a 7 in the tens place. So the 77 in this example actually represents 770, if that makes sense. So my 770 over here corresponds to the 77 over here. All right, so then I do my subtraction just like I did before, right? Subtract. 700 minus 700 is 0. 80 minus 70 is 10. Bring down my plus 7. Okay. So now we do tens into tens, right? How many times does 10 go into 10? 1. So 1 times 10 is 10. 1 times 1 is 1. And then I subtract. 10 minus 10 is 0. 7 minus 1 is 6. Remainder 6. So I get the same answer, 70 plus 1 or 71. I should really put parentheses here because I'm distributing that negative to both of those numbers. All right, questions on the algorithm? So you do tens into hundreds, then tens into tens. We can check again. My divisor is 11, quotient 71, remainder 6, 787. Check. All right, we're going to follow the same procedure where I broke it out by place value, except the hundreds place we're going to think of as the x squared place. And the tens place we're going to think of as the x place. And the ones place is going to be the constant term place. All right, so if I want to divide 6x squared plus 5x minus 6 by 2x plus 3, if I was going to do this with regular numbers, this would be equivalent to doing 600, well, this is weird because it's a minus. Never mind. So arrange the terms of the dividend and the divisor in descending powers of x. Done. Okay. Now, we're going to divide 6x squared by 2x. So I'm going to write this out here. So I have 6x squared plus 5x minus 6, and I'm going to divide it by 2x plus 3. So think of that as like a 23, right? That's 2 times x, and we're treating the x term like a 10. So this is like a 23. So the first thing you do is tens into hundreds, right? Up here before, what we did before, we did tens into hundreds. So I say 2x goes into 6x squared how many times? 3x, yeah. Or alternatively, like if that doesn't make sense to you, you would say, what do you multiply 2x by to make 6x squared? The answer is 3x, right? So I should have written this a little bit lower so that I'd have room to put the quotient. Okay, so 2x goes into 6x squared 3x times. I'm going to put a 3x up here. And then you multiply your 3x times your 23, right? Or 2x plus 3. So you do 3x times 2x and you get 6x squared. And then you have to do 3x times 3 and you get 9x. And you subtract. 6x squared minus 6x squared, 0, so that goes away. 5x minus 9x, negative 4x. Bring down the negative 6. Then you start the process again. 2x plus 3, right? How many times does 2x go into negative 4x? Negative 2 times. So then we have negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6, and we subtract. What do you get when you take negative 4x minus 6 away from negative 4x minus 6? 0. That's a typo there. Bring down the -10. -6. So that's it. I have a remainder of 0. So my answer is 3x minus 2. And I should be able to check if I multiply 2x plus 3 times 3x minus 2, I should get my dividend. Let's check by doing a quick FOIL. 2x plus 3 times 3x minus 2. I FOIL and I get 6x squared minus 4x plus 9x minus 6, which is 6x squared plus 5x minus 6. And that was the dividend that I started with. So this is kind of a way of factoring if you already know a factor, right? If you already know one of the factors, you can figure out the other one by division. All right, you try one. I'll come around and help. All right, I've got x cubed minus 2x squared minus 5x plus 6 divided by x minus 3. Okay, shh. Stop the talking now. Okay, so you say, how many times does x go into x cubed? X squared. Or alternatively, you would ask yourself, okay, what am I going to multiply x by to make an x cubed? X squared. All right, so I put an x squared up here. X squared times x is x cubed. X squared times -3 is -3x squared. Here's where the signs get tricky, right? So I have to subtract now, just like I would with regular long division, but I have to subtract both of these things, right? So I have to distribute a negative sign here. So x cubed minus x cubed is 0. -2x squared minus -3x squared is 1x squared. Then I bring down my minus 5x. And I start again. What do you multiply x by to make x squared? X. X times x is x squared. X times -3 is -3x. And I have to do my very careful subtraction, distributing a negative sign. X squared minus x squared is 0. -5x minus -3x. -2x. Bring down my plus 6. What do you multiply x by to make -2x? -2. -2 times x is -2x. -2 times -3 is plus 6. And I subtract. And I get 0. So this is my answer. And I should be able to check. I could do x minus 3 times that, and I'm going to get the cubic back.
So that's the format you wanted it. Just that.
Yep, that's just the answer. When you divide, get the answer. Yep. All right, so let's do a quick check, just because I don't think probably many of you have never seen how to multiply polynomials that aren't just x plus something, x minus something. So I've got x squared plus x minus 2. And I'm multiplying that by x minus 3. So the way you do this multiplication is you just look at the x first. In the x minus 3, we just look at the x. Distribute the x to every term in the next set of parentheses. So I'm going to have x cubed plus x squared minus 2x. Just distributing the x to every term in parentheses on the other side, in the other parentheses. Then distribute the -3 to every term in the other set of parentheses. So I have -3x squared minus 3x plus 6. And then combine like terms. So I've got x cubed, positive x squared and -3x squared is -2x squared. -2x and -3x is -5x, and the plus 6. And that is what I started with, so I can be confident I did the division right. So that should reinforce here. Polynomial long division is checked by multiplying the divisor with the quotient and adding the remainder to get back the original dividend. This process illustrates the division algorithm. This is just the dividend is equal to the divisor times the quotient plus the remainder, just what we've been doing to do our check all along. The remainder will always be of a degree less than the degree of the divisor. And if something divides evenly into a polynomial, then the thing you're dividing in and the quotient are called factors of f of x. Okay, so before you use long division, make sure that a power of x is not missing in either the dividend or the divisor. So if it's missing, you have to add that power of x with a 0 coefficient, right? Like with real numbers, when I write 703, that means 700, 0 tens, and 3 ones. So if I was doing a polynomial and I wrote 7x squared plus 3, we typically don't use a 0 placeholder, right? But with the division algorithm, you need it. So you would rewrite this as 7x squared plus 0x plus 3, something like that. So if there's a power of x missing, you put it in there, but with a 0 coefficient. It keeps our like terms lined up in the algorithm. All right, so suppose a function, a polynomial function f has zeros at -2, 1, and 3. They all have multiplicity 1. What are the factors of the function? If x equals -2 is a 0, what has to have been a factor? 2 goes into the polynomial? X plus 2, yes. I know what you all meant when you said 2, or like you were all thinking, oh, change the sign to do x plus 2, but you got to say the whole thing, right? When x equals -2 is a 0, that means x plus 2 is a factor. If x equals 1 is a 0, then we have a factor of x minus 1. And if we have 3 as a 0, then we have a factor of x minus 3. All right. And we also know the reverse, right? If we know a factor, if we know that x plus 2 is a factor, then that means -2 is a 0, right? So f of -2 would be 0. And if we know a factor of x minus 1, then you know you have f of 1 equals 0, because 1 is a 0. And if x minus 3 is a factor, then that means f of 3 equals 0. All right, this is getting a little redundant. -2, x plus 2, 1, x minus 1, 3, x minus 3. Okay, so I think you get what I'm trying to say here. If you know one or the then you know the other, right? If you know the zeros, you know the factors. If you know the factors, you know the zeros. So if f of x is a polynomial, if f of c equals 0, x minus c is a factor. And if x minus c is a factor, then f of c equals 0. All right, so we're going to combine these two things, the polynomial long division and the factor theorem, to try to solve a cubic equation, right? We're given one of the zeros is 2, right? -2 is a 0, so that's important. Which means that since -2 is a 0 of this cubic polynomial, then by the factor theorem, f of -2 equals 0, and x plus 2 is a factor. Right. Okay, so I have one of my factors. To get another factor, I could divide, right? So I have x plus 2, and I want to know, what do I multiply x plus 2 by to make 2x cubed minus 3x squared minus 11x plus 6? Yeah. So why don't you take a couple of minutes and do this long division for a bit of practice. Okay, let's go through this together. Shh. Hey, I want your attention back. Okay, x times what is 2x cubed? 2x squared. Okay, so then you take your 2x squared, multiply by your x, and you get 2x cubed. And then 2x squared times 2 is 4x squared. It's positive 4x squared. Then you have to subtract. Right? And I have to subtract this negative sign. I have to distribute it to both terms in that parentheses. So I have 2x cubed minus 2x cubed. Those go away and give me 0. And then I have negative 3x squared minus 4x squared, which is negative 7x squared. Bring down the negative 11x. And start again. What do you multiply x by to make negative 7x squared? Negative 7x. Negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x, and I have to subtract that whole thing. Negative 7x squared minus negative 7x squared. Minus a negative is the same thing as adding, right? So negative 7x squared plus 7x squared, 0. Those drop out. Then I have negative 11x minus negative 14x. That's like adding 14x. So I have negative 11x plus 14x is 3x. Bring down the 6. What do you multiply x by to make 3x? 3. 3 times x is 3x. 3 times 2 is positive 6, and I subtract. 3x plus 6 minus 3x plus 6 is 0. So I have remainder 0, and I knew that I should get remainder 0 because I started out knowing that negative 2 is a 0, so that x plus 2 would be a factor, that it would divide in evenly. So if this is my other factor, okay? And I actually could factor that even more, right? So I could write f of x, my original cubic, as x plus 2, the factor that I was sort of given, right? They gave me that negative 2 is a 0, so I knew x plus 2 is a factor, times, and then I could factor this guy even further, times that quadratic, which factors down to, let's see, it's got to be a 2x and an x. Yeah, my middle term is negative and my final term is positive, so I'm going to have a negative and a negative, because that way when I do the two final terms multiplied together, I'll get a positive, and when I add the middle terms, I'll get a negative. So I got to have a 3 and a 1, and there's only two options. Now it's guess and check. I could put the 3 here and the 1. I could put 3 here and 1 here, or 1 here and 3 here. Yeah, if I put a 3 here and a 1 here, then when I FOIL it, I get negative 6x minus x. That gives me my negative 7x. Division to factor the factor, not unless you have another 0. Yeah. Yeah, if I knew that if I started out knowing that x minus 3 was a factor, I could take the result and divide by x minus 3, and I'd get the 2x minus 1. But you would need to know one of the factors for division to be helpful. Okay, so if I want to use the factor theorem to know whether or not x minus 2 is a factor of this cubic, x cubed plus 2x squared minus x minus 10, I could just do long division and see if I do the whole thing, will I get a remainder of 0, right? But the factor theorem says I have a shortcut. What could I do? Instead of checking if it's a factor, I could check whether something else is a 0. What could I check for 0 status? 2. Yeah. So instead of asking an alternative question to is x minus 2 a factor of that cubic polynomial, alternatively, I could ask, is x equals 2 a 0 of the cubic polynomial? And how can you tell if something's a 0? plug it in, and what should you get? 0. Yeah. So let's plug it in. Let's see. 0 cubed plus 2 times 0 squared minus 0 minus 10 equals negative 10. So 2 is not a 0, which means x minus 2 is not a factor. So x equals 2 is not a 0. So x minus 2 is not a factor. Way easier than doing the whole long division to figure out if it will go in evenly. All right, if I want to use the factor theorem to factor 2x squared minus 3, if I knew the zeros to this quadratic function, I would know its factors. Yes. Sorry.
Why did we put a 0?
Oh, because I'm a dummy. Thank you. We got to plug in 2 and see if we get 0. Okay. 2 cubed plus 2 times 2 squared minus 2 minus 10. Sorry, thank you for somebody speaking up. Plugging in 2 to check if 2 is a 0. Okay, so 2 cubed is 8. That's 8. So I have 8 plus 8 minus 2 minus 10, which is 16 minus 12 is 4, not 0. So same conclusion, right? So 2 is not a 0, means x minus 2 is not a 0, which means x minus 2 is not a factor. Because they gave me the factor of x minus 2. So I said easier to test whether 2 is a 0 than x minus 2 is a factor. Yeah. Right. If it's not a 0, it's not a factor. Okay, sorry. All right, part B. I have a quadratic polynomial, and I want to factor it, which means I want to, do the double bubble. Right? I want to write it as the product of two things. And I can put a 2 out front because there's a 2 in front of this thing, in front of the 2x squared minus 3. So if I knew the zeros of this guy, I would know the factors. How would I find the zeros? Could I do that algebraically? Set it equal to 0. Yeah. So I would say 2x squared minus 3 equals 0. So 2x squared equals 3. So x squared equals 3 halves. So x is plus or minus the square root of 3 halves. So if those are my zeros, I know my factors. X minus square root 3 halves, right? That's for the positive. X minus positive 3 halves. And then x minus negative 3 halves, which is x plus radical 3 halves. And I've got it factored. All right, last problem together, and then you're going to work on some stuff. I've got a polynomial graph here. I would like to write a possible equation for this graph. So I'm going to put it in factored form. So we'll call this thing f of x. And it's some leading coefficient, x minus 0, x minus 0. How many zeros do I have here? 3. Okay. This 0 right here at negative 2, what factor do I have? If negative 2 is a 0, x plus 2. Thank you. So x plus 2 is a factor. But Do you think the multiplicity of that 0, is it even or odd? Odd because it goes through the axis. If it goes through the axis looking like a straight line, it's usually multiplicity 1. If it kind of flattens out like this, it's a higher multiplicity than 1. So let's just give it a 3. Okay. Multiplicity 3, so that means that that 0 happens 3 times, which means that the factor happens 3 times. So I put a cubed on it. All right, this x minus 0, I could write x minus 0, or I could just write x, because x minus 0 is just x, right? And what do you think the multiplicity is on that 0? 1. It's definitely odd because it goes through the axis, and it's 1 because it goes through like a line. Okay. And then this last one, at x equals 1, means I have a factor of x minus 1. And how many times should I include that factor? Twice, because it bounces off the axis. It's got even multiplicity. So I'm just going to put a 2, the smallest even value. And then what has to be true about that a value? Positive, because it's a both arms up and behavior. So I don't know exactly what it is, but I could figure it out, actually. I know a has to be positive, but I could figure it out exactly what it is. Because do I have another point on this graph other than the zeros? Well, I kind of use the y-intercept. Yeah, because that's one of the zeros. And the other point that I haven't used? It's hard to tell the value of that. Just any place that it crosses a grid line. Right here. Looks like -1, -2. So I have a point. If you have a point, you can figure out the a value after you've got the zeros and stuff set up. If -1, -2 is a point on this graph, plug in -1 for x and -2 for y, and we'll solve for the a. So I'll put in -2 for the y, don't know a, and I'm going to put in -1 for all my x's. -1 plus 2 is 1, cubed is 1. -1 minus 1 is -2. When you square -2, you get close, +4. So when I solve for a here, divide both sides by -4, and I get a is 1/2. So now I have the entire equation. I know that f of x is equal to 1/2 times x plus 2 cubed times x minus 1 squared. So you start putting in the zeros, translating zeros to factors, and then at the very end you solve for a by plugging in any point.